Hello everyone, welcome to online lecture series of electronic devices. The subject code is KEC301. I am Dr. Sapna Katiyar, Professor in Electronics and Communication Engineering Department at ABE's Institute of Technology, Ghaziabad. This is lecture number 31 and today's topic is N-channel depletion type MOSFET. So today I am going to discuss MOSFET. In previous sessions, we have discussed about the junction, BJT, so many things we have discussed, but this is the first session, first lecture for the MOSFET. So let us begin. What you are going to study? First, I will be discussing about the different types of FETs. You must be aware about the all types of FETs, field effect transistors. Then oxide semiconductor field effect transistor, which is the MOSFET. Difference between the MOSFET and BJT. BJT you have already studied. So you must be aware what is the difference between the BJT and MOSFET. Then N-channel depletion type MOSFET. What is N-channel depletion type MOSFET, which is actually the major topic of today's session. Right? Let us begin one by one. Different types of FETs. FETs, field effect transistors. There are two types of FETs, two types of field effect transistors. One is the MOSFET, which I will be teaching you in today's session. Other is the JFET. JFET, from the name itself, it is clear. J denotes the junction. It is junction field effect transistor. Junction field effect transistor is of two types, N-channel and P-channel. Now let us discuss about the MOSFET. MOSFET is, M denotes the metal, O is for oxide, S is for semiconductor, FET field effect transistor. So MOSFET is metal oxide semiconductor field effect transistor. It is also one of the type of FET, and MOSFET can be of two types. It may be of depletion type, it may be of enhancement type. You have to study both the types, depletion as well as the enhancement. And in both types, depletion it may be a N-channel, P-channel. For enhancement it may be a N-channel or P-channel. So in today's session, I will be discussing about N-channel depletion type MOSFET. But besides this, you must be aware with the other types as well. See, MOSFET, it stands for, as I have told you, M is for metal, O is for oxide, S is for the semiconductor, FET field effect transistor. So MOSFET is metal oxide semiconductor field effect transistor or metal oxide silicon, because silicon is the commonly used semiconductor material. It is also known as IGFET. IGFET is insulated gate field effect transistor. What do you mean by insulated gate? Here gate is not directly connected with the substrate. There is the insulation in between the gate terminal and the substrate, in between the body, means there is the oxide layer. That is why it is known as a insulated gate field effect transistor. And MOSFET can be operated in both enhancement and the depletion, enhancement and depletion mode. It uses either of channel. Channel may be of N-channel or P-channel. If N-channel is there, it is known as N-MOSFET. If P-channel is there, it is known as P-MOSFET. And silicon is the major choice of semiconductor which is used for the manufacturing of the MOSFET. But some manufacturers uses silicon germanium. This particular combination is also used by some of the manufacturers. There you have studied the other types of semiconductors also. You have studied about the elementary semiconductor, you have studied about the compound semiconductor. So there is one semiconductor, gallium arsenide, which is commonly used in the formation of the other devices, but this is not the preferable one in the case of the MOSFET, because they do not form a good gate oxides. They don't form good gate oxides, means it doesn't provide good insulation in between the gate and the body. That is why this particular semiconductor material is not the preferred one. Now let us discuss in the basic about the MOSFET. The construction, if you see the construction of the MOSFET, this is very similar with the FET, field effect transistor. Here you can see a oxide layer. This oxide layer is deposited on the, here a n-type substrate is being taken. Upon this n-type substrate, a P region is being created, and in between this substrate and gate, this is a layer, oxide layer, SiO2. This layer is being deposited over here, and this oxide layer, it acts as an insulator. It keeps separate the gate with the body. So in this particular construction of MOSFET, a lightly doped substrate is diffused with heavily doped this particular region. And MOSFET is commonly used for the switching applications, for amplifying signals, commonly used for switching applications, for amplifying signals. And as if you were studying in the case of the BJT, that BJT is a current control device, FET is a voltage control device. MOSFET is a kind of FET, it is a voltage control device. Here input voltage controls, that is why this is the voltage controlled field effect transistor, right? All the terms you must be aware with. As if I have told you, you have studied the BJT, now you are studying the MOSFET, so you must be able to understand, you must be able to differentiate between these two. What is BJT, what is MOSFET? See, we can differentiate on the basis of certain parameters. If we talk about the device type, right now I have told you that BJT is a current control device, while FET is the voltage control device. Second parameter is the current flow. In case of BJT, BJT is what? Bipolar junction transistor, and from the term bipolar, it is clear that the current is carried by both type of charge carriers with electrons as well as the holes. That is why it is bipolar. But in case of MOSFET, it is unipolar. Either of the charge carriers, it may be electrons or holes. Terminals. In case of BJT, once it has been designed, if the manufacturer had designed, left one is the emitter terminal, right one is the collector terminal, it cannot be interchangeable because their functions are clear, their doping levels are different, their area is different. So it is not interchangeable, while terminals are interchangeable in the case of the MOSFET. Operational modes. In MOSFET, it operates in enhancement and depletion, while in BJTs, no such mode exists. Input impedance, very high. Here input impedance is low in case of the BJT. If we talk about the output resistance is low in case of MOSFET, while output resistance is moderate in case of the BJT. If we talk about operational speed, which is a very important parameter. So operational speed is high in MOSFET, while operational speed is low in case of the BJT. So all these parameters are very important. Noise is low in MOSFET, while noise is high in case of BJT. Thermal stability is high in MOSFET, while thermal stability is low in case of the BJT. So all of these are very important parameters upon basis you can differentiate the both MOSFET with the BJT. Now let us discuss about the N-channel depletion type MOSFET. What do you mean by this N-channel depletion type MOSFET? You can see in this particular diagram, as I have told you, a P-type substrate is being taken upon which a highly doped N regions have been created. These are for the source and drain. This is source, this is gate, and D is drain. Si over here, upon this a oxide layer is being deposited, SiO2. This SiO2 layer, it provides the insulation in between the gate and the substrate, and for these terminals, for these wires to be created, a metal is to be deposited over here. This is the metallic contact. In some of the cases, the source and substrate are internally connected. So, that can be viewed as a 3 terminals. Here you can view it as a 4 terminals. The 4 terminals named as source, gate, drain and substrate, right? So, if we are talking about N channel, what we mean by this N channel, you can see since highly doped N points have been created for the source and drain, now diffusion takes place, and because of the diffusion this N channel is created. This is the N channel. That is why it is known as a N channel depletion type MOSFET. N channel is simply known as a NMOS. Here a lightly doped P type substrate is taken, into which 2 heavily doped N regions are diffused, and these N regions are source and drain. In between these 2 regions the channel is formed, and this channel is because of the diffusion which connects source to drain. As I have mentioned, a thin layer of SiO2 is deposited over there on the entire circuit to draw the ohmic contact for the source and drain terminal. And because of the presence of this SiO2 layer between the gate terminal and channel, you can see this is the SiO2 in between the gate and the channel. Input impedance is very high over here, and there is no direct contact between the gate and N channel MOSFET. That is the major difference between the JFET and MOSFET. Here there is no direct contact, and this is actually the difference between the junction field effect transistor and metal oxide semiconductor field effect transistor. So these are very important points. You would like to understand the symbols. You can see these are the simplified symbols for N and P. Most commonly you will find this particular symbol. Here you can see the arrow is inward. You are drawing for N channel depletion type, arrow is inward. Current flows from source to drain. That is what, when I am going to explain the working of this, you will be able to understand. You can see in between gate and the source drain there is a gap being mentioned, the insulation, and here the difference when you will study the enhancement type also you will find a difference. In case of enhancement, this line is the dotted line, while in case of depletion this line is the connected line. So that is the major difference. You can differentiate if the 2 symbols have been drawn, if you have to identify which is the enhancement, which is the depletion type. Just you observe this particular line. In depletion this will be the connected one, in enhancement that will be the dotted one. So this is the symbol which you will be using in the circuitries whenever there is a requirement to design it. G for gate, D is for drain, S is for source, B is for body, and sometimes substrate, SS is also mentioned, either B or substrate. So the circuit symbol also you must remember. Now let us discuss its working in detail. What happens? Because now you know what is MOSFET and how it can be designed, but how it actually works. You can see the first case. 3 diagrams have been shown over here for the 3 different cases. Case 1, when VGS is 0, what will happen? You can see there is a P-type substrate upon which N portions have been diffused to make the source and drain. VGS is 0, right? At the same time, positive plus VD is applied over here initially. Now what will happen? You can see, because this is a P-type substrate, this is N, depletion layer will be formed over this junction. At the same time, depletion layer will be formed at this junction. But when VGS is 0, now you can see there is a channel which is being absent over here. But if you apply positive VGS, positive gate voltage, second case, positive gate voltage. See, VGS is 0, right? You have applied positive gate voltage. What is happening? Because of diffusion, channel is created. You can see this particular channel. This is a p-type substrate. In p-type substrate, the majority charge carriers are here, holes, and minority charge carriers are electrons. Majority charge carriers are holes and minority charge carriers are electrons over here, right? But when positive potential, positive voltage is applied at gate, now what is going to happen? You can visualize, see, plus is being applied over here. Now, in the case of p-type material, see, in this particular channel, you can observe in this particular manner. In this particular channel over here, electrons are the majority charge carriers. Now, what will happen? Electrons are the majority charge carriers, so they will be attracted towards the gate terminal. At the same time, because in p-type, majority charge carriers are holes, so holes will be repelled away. But the electrons which are in the minority into a p-type substrate, these electrons will be attracted towards the gate terminal. So now what will happen? When you keep increasing this voltage, positive voltage at gate, then these electrons will move towards the gate and more electrons, even this minority charge carrier, they are also going to participate, means now current will increase. See, as the channel forms, drain current flows, but when more and more electrons are repelled over here, pushed over here, so drain current increases. ID is the drain current. So upon increasing gate voltage, drain current increases, right? Now let us discuss the third case, when VGS is negative. Now what will happen? When VGS is negative, you can see negative potential is being applied over here. In the channel here, the charge carriers are electrons. Now because of this potential, these electrons will repel, right? And holes which are the majority charge carriers in p-type substrate, these holes will be attracted towards the gate terminal. Now recombination will happen. Recombination of electrons and holes will occur over here. And when this recombination occurs, then drain current decreases. So upon increasing this negative potential, if you increase this negative potential when VGS is negative, and if you keep increasing, drain current will decrease. And this is the reason more recombination happens and current decreases, and up to a certain voltage, this current will decrease sharply. That particular voltage is denoted by VT. So this is the case when we are discussing about all the three cases when VGS is 0, when VGS is positive, and in this particular case, what will happen if we keep increasing the positive voltage, and the third case is when VGS is negative. So I hope now this particular point is clear to you, how to draw the characteristic curve and how to explain its working. Now let us draw the drain and transfer characteristic curves. See, as if you have to draw the characteristic, you need to understand the characteristic curve. So for the case of MOSFET, you must remember, you have to plot the transfer characteristics as well as the drain characteristics. First, let us discuss about the transfer characteristic. Transfer characteristic curve is being plotted in between the VGS and ID, right? VGS is the voltage between gate source, ID is the drain current. So in between VGS and ID, this curve is going to be plotted. Now recall what we have discussed in the case of the MOSFET working. What we have discussed? We have discussed the three cases. When VGS is 0, when VGS is positive, and when VGS is negative. When VGS is 0 and a positive voltage is applied between drain and source, Now what happens? A current flows and that current is known as or represented as IDSS, right? So this is a point when VGS is 0 and this particular value of current, this is nothing but IDSS, right? Now recall the remaining two modes, when VGS is positive and when VGS is negative. When VGS is positive, what is going to happen? Just let me give you an overview. See, this was the case when VGS is positive. You can see when it is positive, positive is being applied at the gate terminal. Here electrons are available in the channel. Because of this, positive electrons will be attracted towards the positive terminal, which are already available over here. But in this p-type substrate, recall in the case of p-type semiconductors, the majority charge carriers are holes, minority charge carriers are electrons. Because of this, positive holes will move towards right, the majority charge carriers, but some of the minority charge carriers exist in p-type semiconductor, and because of this applied positive, these electrons will be attracted towards the gate and they are going to contribute in the conduction process. So what happens if you keep increasing Vg, then current will increase. See, in this case, if you keep increasing VGS, gate source voltage, then ID, this current increases. This is the value IDSS1, this is IDSS2, IDSS3, right? This is the case when VGS is positive and you keep increasing. The third case, when VGS is negative, you can see this particular portion. Now we are discussing about this. What happens when voltage at the gate terminal is negative? Gate is negative, channel is available over there. In the channel, electrons are present. Now what is happening? Electrons are pushed out towards the p-type, right? And from p, the majority charge carriers, which are holes, they are attracted. So the recombination occurs, right? So in that particular manner, this ID decreases, and this decrease, it will keep decreasing if you are increasing this potential in the negative. The drain characteristic curve, see, it is being plotted in between VDS and ID, right? You can see on the x-axis VDS is being taken, on the y-axis ID is being taken. When you increase VGS, ID will increase, and here you can identify this curve in between two regions. In between A to B, it follows Ohm's law, ohmic region. Here it follows the square law, saturated region, and this is the cutoff region. So just remember, upon varying one factor, how the other factors are varying. See, the simple case. So this is how you can plot the transfer characteristics and the drain characteristics of a depletion type MOSFET, where N channel we are talking about. So N channel depletion type MOSFET. Thank you so much.